Hi, I'm Stephan. I am responsible for AVL mobility technologies in the US, and I'm here with Walde today, who's responsible for our advanced simulation technology organization. I want to talk a little bit about simulation technologies and how important they are in today's world of mobility, both on the ground, in the air, and even going to the moon, and talk about how companies take advantage of it and also the areas companies take advantage of it. And obviously some of the solutions we have at AVL that really help in the mobility space advance and move technologies faster and faster at a shorter time frame and with more accuracy, higher quality, etc. What makes, I know there's a lot of different simulation companies out there, right? We have an ANSYS, we have Dassault, we have Gamma Technologies, we have Siemens, who has acquired a lot of smaller, more niche players, as you have also explained to me. So then we have AVL. So what makes your team unique, your solutions unique?
I would say that one of the major things is that we have a solution that can be used throughout the entire development process. So all the companies, or most of our competitors, they have solution for a specific part of the development process. They have tools that are really good in CFD, but they need a different tool that supports what the inputs that are needed there. So in AVL, what we have is a tool change that can be used throughout the entire development process. So and all that is thanks to the platform in what we develop. So basically what we develop is a platform in where the user enters at the beginning of the process from, let's say, from zero, from scratch, and can end to the end of the process using the same platform. So all our tools, this is what we discussed about having 1D, 3D, having 0D tools, all sits on the same platform. So meaning that the user does not need to learn like 30 different tools to complete the entire process. So I would say this is one of the major thing that we have with our tools. And I would say the second, that is maybe the most important one, is that we have key users within our companies. So the first user of our tools is basically AVL. So the AVL engineers that they do work and they develop these technologies within AVL, they use our tools to do the work. So meaning that we have the direct loop between the engineering and what is needed for the tools to be transferred.
Immediate feedback, so to speak. Yeah.
Exactly.
If you had to do a presentation today to a group of OEMs, we're not talking suppliers, but let's talk OEMs for a moment, to a group of OEMs that are all interested in how can they improve and make more use of simulation, because simulation is, in my opinion, I mentioned this before, is really in my opinion, the enabler of the future of mobility, right? Not only because technology gets more and more complex, but also we need to go faster and faster and faster. So with you guys now working in this space, or AVL working in this space for whatever, 20 plus years, right? If you take the last 5 years, so from the end of, let's say, 2015 to the end of 2021, what do you see OEMs are not doing yet enough with simulation, or what areas are they still hesitant? And I know different OEMs are in different places, right? We may have one that's heavily reliant on simulation and one that's absolutely not. So let's go to the middle one. Let's go to the average. What would you tell them the two main areas that they should really look into and make more use of simulation or digital twins or whatever it might be is?
Yeah, I would say there's one area that OEMs are not really exploring too much, that is the virtual calibration. Okay, so there are OEMs in where, as you said, so the entire development process is now a simulation process, simulation-based process, and we have seen that actually those companies are able to reduce the standard SOP time by doing so. But most of the companies still rely in the early phase of development for simulation. So simulation is used for the design phase, for the concept phase, for the layout phase. But then there is like a big jump between, okay, what we do in simulation, what we are now doing in a test bed. So what some of the tools or let's say what some of the OEMs are doing in a really proper way is to connecting these two words, connecting simulation with testing. So, and this normally happen at the later stage of development. When it comes to calibration, when it comes to function development, this is something that need to be more integrated for some OEMs, because there is when you save time, there is when you really make use of the digital twin. So digital twin is, I know there are different definitions of that, but so once you have a hardware defined, you can basically take that hardware, move this into a virtual environment through simulation, and use exactly the same that you try to do in a physical environment just by simulation. The thing is, by the means of simulation, you can do it faster, you can do it much more iterations, and you can even go to conditions in where with your physical hardware it's not even possible to do that, because there's limitations, there's let's say areas that you cannot enter with your test.
Okay. So that same group, they would say, okay, this is all great, we're going to do this, but what's next? So then the question comes up of, okay, what is next? With all these advancements we've made over the last 5 years, let's say only in simulation, right? With all the things you already mentioned, what's the next thing in simulation? I mean, in the mobility space, we're not talking about level 4, level 5 autonomous driving. That's the next thing, right? There's artificial intelligence, machine learning, advanced sensor technology, better connection to the cloud, all of these things. What's the next thing? What's the new frontier, the next frontier in simulation?
I think you already mentioned a key points, so that I would think is where we need to go with simulation. So I think simulation, once it is accepted and adopted over the entire development process, then we need to start to think, okay, what are we doing with all this data that we generate with simulation? I think the parts related to data analytics and also to the artificial intelligence and machine learning is something that need to be connected with simulation. So now we have, let's put this example in where we have a digital twin. So now if we have this in a virtual environment, there is endless possibilities to play with that and to find the optimal solution. So, but how we do that in an efficient way, how we do that, how we optimize that process, and how we make use of all this data that is generated through simulation. So I think connection with data analytics, artificial intelligence, and machine learning is the next step, is where we need to go. Okay. So one thing to keep in mind with simulation is that normally we see more data than when we do a physical test. So because we can see what is happening, let's say 1 or 2 layers inside of the different components, inside of the different elements. So some information that normally we don't have when we do tests, but when we do simulation, we can go to all this. But so this generate immense amount of data. So now we need to know, okay, what we do with all this data that we generate.
Okay. And maybe last question for Walde. We've talked about before the importance of AVL's tools also being used by the AVL engineers on the test system side, on the technology development side, just across the board, right? And then having our customers or others adapting it as well, and how important that is because of the closed loop feedback, so to speak, we have. Are you also there talking about the importance of domain knowledge? So somebody like an AVL that uses it, that your group then is developing the software, comes with a lot of domain knowledge that maybe other other suppliers of simulation technologies may not have. They see a need, they develop the simulation, but they may not have either the background, the domain knowledge, understanding. How important is domain knowledge?
I would say this is one of the most important things that we have. So tools are out there, but without having a proper input, having a person that really knows how to manage the tool, basically the results are not useful. So yeah, we need to have this domain knowledge, and we need to have also this know-how transfer to our customer. This is a pretty important topic that we really take care and take into consideration when we deploy our tools in our customer. It's okay, it's not just having you the tool is helping you how to use the tools in an efficient way, in an optimal way, because otherwise a tool will be sitting there without having the proper interaction, without having the proper input. It will not give the output that we all are waiting.
Okay. So this is what we see as, again, as we just heard from Walde here, simulation definitely is the enabler of the future, or one of the key enablers of the future of mobility. And hope this was helpful. And I don't know, Walde, a last word about simulation, maybe from your end?
Yeah, maybe just a few things. So I think simulation is something that we are going to see more and more in our industry. Simulation is what will help us to, let's say, with this revolution that we are having now in the mobility space. And as I said, so it is something that it will be so integrated into the development process that once we reach this level in where the user does not know that they're running simulation is when we are start to use this more in an efficient way.
Thank you.